Hello and welcome to the 2D Quality Inspection Tools video in the Signova series. In this tutorial I will show you how you can easily inspect the quality of your parts. I use the chocolate samples to measure the position of the packaging in relation to the chocolate bar. To follow along, get yourself an Inspector 830 with the Signova sensor app and download and print the chocolate sample wrappers. My Inspector 830 is mounted parallel to the table with a distance of around 35 cm. It's connected to my PC using the USB-C service interface as it's super easy, but Ethernet works fine as well. To access the user interface, open a web browser like Google Chrome and enter the default IP address of the USB connection 169.254.0.1. To make applying the analysis tools way easier, place the chocolate straight and centered in the field of view. If your image is not as sharp and valid as mine, I recommend to watch the Image Acquisition Inspector 830 tutorial. Switch to Configure in the top right corner and click Update Reference Image below the live image. You will automatically switch to the Reference tab. There I will first apply the Object Locator tool on the brand logo to locate the chocolate bar in the field of view. Let's find the relevant edges using the Line Fitter tool and, in a later step, measure the distance and angle between them. To find the top edge of the wrapper, select the Object Locator, click on Add Tool in the Analysis section and select Line Fitter. The Line Fitter searches for straight edges across its search direction and fits a line to it. Rotate the region of interest until the blue arrows indicating the search direction are perpendicular to the relevant edge. Move the Line Fitter region onto the edge and adjust the size to just include the center section. Switch to Live, select Free Running and move the chocolate bar around. As long as the Object Locator and Line Fitter are green, the localization works fine. Switch back to Reference. For easier mapping, I recommend to rename the tool, so right-click on the Line Fitter, select Rename and change the name to Wrapper Top. Now let's find the left edge of the wrapper. To save time, I copy the existing tool, but you can also create a new one. Right-click on the Wrapper Top tool, select Duplicate to copy the selected tool with all settings and rename it to Wrapper Left. Move the Wrapper Left region to be centered over the left edge and rotate using the large green handle until the blue search direction arrows are perpendicular to the edge. To improve robustness, I changed the polarity setting to bright to dark, so only contrast transitions from bright to dark along the search direction are included. And last, I want to locate the top edge of the chocolate bar. Duplicate the Wrapper Top tool and rename it to Chocolate Top. Move the chocolate top region to include the top edge of the chocolate and change the polarity to bright to dark. My chocolate bars are wrapped in a transparent film, causing shadows and reflections, so I need to adjust further settings to reliably find the chocolate edge. To do so, expand the advanced sections within Settings on the right. As the foil can cause multiple contrast transitions across the search direction, change the edge selection to Last. This should always be the chocolate itself. These disturbances can also create blurred and uneven edges on my samples. To get a stable detection of the edge, I increase the edge fuzziness parameter to 10. Now that all relevant edges are found, I measure the distance between the top of the wrapper and the top of the chocolate to check its correct position. Click on Add Tool and select Distance. On the right, select Wrapper Top Line as Feature A and Chocolate Top Line as Feature B. By default, the distance is measured point to point, here the center point of the chosen line sections. Change measurement type to right angle to measure the shortest distance between these features. Find the distance value in the Results section. It states around 225 pixels. In case the results should be in millimeters instead of pixels, you can calibrate the camera for the specific setup. The measured distance can be used as a pass-fail criteria easily, so I set the expected value to 230 and define the tolerance as 10 pixels. To ensure that the rotation of the wrapper is within tolerance, we measure its angle. Click on Add Tool in the Analysis section and select Angle. It measures the angle between two lines. In my case, I set the reference line to Wrapper Left line and the secondary line to Wrapper Top line. Find the angle value in the Results section. It states around 90.2 degrees. The expected angle is 90 degrees, so I set Expected to 90 degrees and choose 1 degree as the allowed tolerance. Now let's switch to live and test if our configuration works as expected while placing and moving different chocolate bars around. In case the chocolate bar sticks out of the wrapper too much or too little, or the angle is out of tolerance, the tools will report a fail. Wow, that was easy, wasn't it? Quality inspection tools can be used in a wide range of industries and applications. For example, inspecting the correct placement of bottle caps or verifying the position and critical dimension in electronic devices. In the upcoming tutorials, I will show you how to perform even more advanced inspections using the AI tools in Signova. If you can't wait to get started, contact your local SIG sales representative now to find out more about the incredible world of Signova.